Welcome to LIB Academy. In this video, I am going to take you through expectation value of the Hamiltonian operator. In quantum mechanics, there are some identities that we need to know to help us in our journey in quantum mechanics. The general form of the time-independent Schrodinger equation can be written as h hat psi equal E psi. And we know that the general definition of an expectation value can be written as this in 1D, where h is the expectation value of the observable h and psi star is the complex conjugate of the wave function psi, and h hat is the operator of the observable h, which is the Hamiltonian. And before we continue, what exactly is an expectation value? Expectation value is a theoretical average of all possible outcomes when measuring specific physical quantity on an identical quantum system. For instance, if you measure the position of an electron repeatedly, the result may vary because quantum mechanics is probabilistic, and the expectation value gives the statistical average of all those measurements. It basically gives you the average of all those measurements that you performed repeatedly. So that is what expectation value is. Notice that in quantum mechanics, we are mostly dealing with probabilities. So the expectation value is not necessarily the most probable value. All right, let's continue. So now, let's group this term here. Positive infinity, psi star, h hat, psi. Let's put this term here into bracket and compare the value of what is in the bracket here to the general time independent Schrodinger equation. H hat psi is the same as E psi. So let's replace H hat psi by E psi. So we are going to get integral from negative infinity to positive infinity, psi star, E psi, E psi, dx. Don't forget expectation value of the Hamiltonian. So what next? Since E here is a constant, let's try factoring it out. So E integral from negative infinity to positive infinity, psi star, psi, dx, expectation value of h. So what do we see? This term here can also be written as E integral from negative infinity to positive infinity, absolute psi squared. This is termed as the probability density. In our previous video, we proved that probability density for a stationary state is constant. Probability density is the same as psi star multiplied by psi, which can be written as psi squared or absolute psi squared. So anytime you come across this, it's called probability density. The probability of us finding an electron in space when we integrate across the entire space. That is from negative infinity to positive infinity. And from the normalization theory, if an electron exists in space, and we are finding the probability of finding that electron in space integrating over the entire space. The probability for us to find an electron should be maximum. It must be equal to 1. So to proceed with this expectation value of H, this term right here will equal 1. So expectation value of H should be equal to E multiplied by 1, which is the same as E. So this is where we end. And what does this mean exactly? The expectation value of the Hamiltonian operator, the Hamiltonian, is equal to the allowed energy value of the stationary state. So this is what you have to know. Another identity you have to know in quantum mechanics. The expectation value of the Hamiltonian is equal to the allowed energy value for a stationary state. So that is it for this video. Feel free to check out the playlist, my playlist on quantum mechanics. See you in my next video. If you found this video helpful, kindly subscribe to my channel and give a thumbs up to this video for more educational content like this. You can also refer my channel to your friends. Thank you. Bye.